Let's look at the question that we do have in front of us. Is a tree diagram. So the tree diagram says to us the customer has 3 meals. So already we know we are going to be dealing with a base of 3. So we've got this base of 3 over here. That's extremely important. Don't ignore that, okay? And the meals that this person is dealing with is a 2-piece McWing, a McDouble burger, and a McChicken burger. So those are the 3 things we are dealing with. And if you go down here, you can see exactly what it is that they are talking about. So we've got our McWings, which is the first option. We've got the McDouble, which is the second option, and then the third option has not been put in. It means there's a reason why it has not been put in, okay? The third option is a McChicken burger. We've got that McChicken burger there, and then we've got the side happening. Oh, I'm already hungry just looking at this. The 2 sides that we have with these options is that you could either have fries or either have corn. Okay, so you could choose from those 2 options. And we've got this nice tree diagram that we have down here, and we've got that little point over there where the tree diagram begins. Whenever you are asked to draw your own tree diagram and it's not drawn for you to fill in, there's a point where your tree diagram should begin. And because this person has 3 options, this is the first option, the second option, and the third option. And remember, I said to you guys, the base is 3. Meaning this is the base that we are working with, okay? And because that's the base, it means that it's going to be the denominator in this particular section that we are working with. And I say this particular section because if you move here, the base is 2, but I'll tell you why the base is 2 in that particular section. So we have our first option, which is the McWings that I've spoken about, the McDouble, and then the third option, which is not written in there, but we are told what the third option is. Let's look at what the question says to us. The question says, complete the tree diagram to illustrate the various options the customer has to choose from. So the first option we have there, and we can see the empty spaces. The empty spaces is that space over there, this space over here, and that space over there as well. I'm going to erase all of that so that we do not have a problem in terms of being neat. I don't want it to be a problem. So let's start from scratch and fill this tree diagram in. So the base is 3 over here, so I'm going to work with 3. I know that's a 3 already. And whenever you want to see what to fill in that little space over here, I'll call that X, you need to say to yourself, probability is always out of 1. Okay, and I know it sounds really weird. Whenever you're working with fractions or whenever you're working with decimals, always remember that probability is out of 1. So whenever you are trying to figure out whatever the missing value could be, all you could do is say 1 minus whatever the fractions are, or you could do the following. I know that 1, and if the base is 3, it has to be 3 over 3. So I know that 1 is equals to 3 over 3 in this particular case because the denominator that we are working with is 3, okay? Let's look at how I'm going to find that missing value. I'm going to break it down for you, so be patient with me. So if I were to go and break it down and try to figure out how I would find that missing value, I said to you guys that everything is out of 1, okay? I would say 1 minus the 1 over 3 that we've been given minus the 1 over 3 that we have been given as well. We've been given 2 minus 2 thirds over there. We've been given this third and we've been given this third. And we know that this entire thing needs to be 1. So I've subtracted everything from that. What am I going to do now? I'm going to go and I'm going to calculate that. There we go. So 1 minus, I can put it as a fraction so that it doesn't confuse me, minus another third. It's a fraction again. So do it like that so it doesn't confuse you. It means that the remainder is going to be 1 over 3. So the remainder is 1 over 3. Let's go now and fill that in where we are supposed to be filling it in. I'm going to just erase that x over there, and that makes it 1 over 3. So I know 1 over 3 plus 1 over 3 plus 1 over 3 should give me this 1 over here, because everything is out of 1 when I am working with fractions or decimals, as I've mentioned before. The next open space is this over here, okay? And we've been given the 3 options: McWings, McDouble, and the third option that we have been given is going to be the McChicken burger, okay? So I'll just write there, McChicken burger. Stunning. Okay, I've got that. Stunning. What is the next thing that is missing over here? The next thing that is missing, I'm just going to erase that little X over there. The next thing that's missing is this over here. So I've been told that I've got 2 sides as an option, and the 2 sides go with every meal. So it means that when I have the McWings, I must have my fries and I must have my corn. And when I have my McDouble, I must have my fries and I must have my corn again. With my McChicken, I must have my fries and I must have my corn again. So in this particular case, the McFries already, the fries are already put in. So it means that the missing one is the corn. And the reason why it's 1 over 2 is because you've got 2 options. You've got 2 options. So it's 1 over 2 and 1 over 2, making that half. So that's how you fill in your tree diagram. Whenever you are filling in your tree diagram, please do make sure that you've got all the options that have been given to you. Sometimes you'll be asked to draw this tree diagram from scratch. You do not want to be found wanting in terms of that. So you want to know how to draw a tree diagram all the way from scratch. Am I saying there's going to be a tree diagram in every paper? No. But you want to be ready in case you are asked for a tree diagram. Let's look at the next question in this particular tree diagram that we have been given. It says to us, using the tree diagram above, determine what the probability is. So there we are being asked to determine the probability. Probability is just a fancy word for chance. If someone says to you, what is the probability that it's going to rain today? They're saying to you, what are the chances that it's going to rain today? Okay, so probability is just a fancy word for chances. Don't be scared and feel like, oh my goodness, what are they talking about? And in terms of probability, they're also trying to say to us, listen here, it might not be 100%. It's not going to be 100%, but there's a chance, or there's a big chance, a small chance, or no chance whatsoever. So this particular one is asking us now, what are the chances of? Okay, so it says to us, using the tree diagram above, determine what the probability is, determine what the chances are that the customer will choose a McDouble burger and fries. And in that particular case, we need to go to McDouble burger and we need to go to fries. But we need to use, our denominator needs to be the outcome. Okay, so I'd put a little outcome thing over there. It's good that you know how to draw outcomes even when the outcomes are not being asked for. Okay, so I know that in this particular case, I've got 1, 2, 3, 4, 5, 6. So I know I've got 6 outcomes. So my denominator is going to be 6. Whatever that I'm going to be calculating, the denominator is going to be a 6. So I am now asked what the probability is going to be that I would choose a McDouble burger. And that's a McDouble burger that we're looking at over there with fries. Let's go see. So there's the McDouble burger. It's a combination of 2 things. And then there are the fries over there. And if we were to go and combine these 2 things, I'm going to do something we haven't been asked over here. And I'm just going to write the outcomes, because sometimes the outcomes are asked from us. So I'm going to say McWings and fries, McWings and corn. And then I'm going to say McDouble and fries, McDouble and corn. And then I'm going to say McChicken and fries, McChicken and corn. So I've got my 6 outcomes, even though I haven't been asked for the outcomes, okay? I've done that so that I can have a denominator, because whenever we are asked for the probability, the best thing you can do is start with the fraction. So what are we being asked again? A McDouble burger and fries. So I've got my McDouble burger again there, and I've got my fries over there. Is there any other place where I can have a McDouble burger and then have fries? No, there is no other thing. So it's just 1 over there, and it's 1 out of 6. Probability is always out of something. So the probability is then, let's just say that's 1 and that's 2. So the probability of choosing a McDouble burger and fries is 1 over 6 chances. 1 over 6 things, okay? And then if you are not asked to give it as a percentage or to give it as a fraction or as a decimal, just give it as a fraction, okay? You will get your marks as they are. Look at how many marks you are being given as well. In this particular case, I'm going to show you how to convert this fraction into a decimal, and then how to convert this fraction into a percentage using your calculator. Anytime you convert something into a percentage, you need to multiply by 100. So I always say that's the key word. Anytime you hear the word percentage, it's something that's out of 100. Anytime you need to convert something into a percentage, you need to multiply it by 100. So let's convert 1 over 6 into a percentage. So that would be 1 over 6 times 100, which changes it into a percentage. And you know our lovely calculator gives it to us here as a mixed fraction. So I'm going to press change, and then it's going to give me an improper fraction, and change again, and it's going to give me 16,66666 with a 7 at the end there. I'm going to round it off to 2 decimal places, so I'm going to make it 16,67%. So multiply that by 100, and it would give me 16,67%.